This is part 2 of our series on approaches into Merced Regional. Still going to runway 30, this time coming in from the northwest, almost a straight line into the opposite end of the runway. So what we'll be doing on this approach is we'll be doing the procedure turn, depicted here as a standard hockey stick turn. Arriving from the northwest, we'll fly outbound on the localizer, but in the reciprocal direction, the 1, 2, 3 degree direction, until we reach the point where our procedure turn occurs. This turn being made to the right, 164 degrees. So we'll fly in from the northwest, intercept the localizer somewhere prior to our initial approach fix coupe intersection, and then fly outbound on the localizer heading 1, 2, 3 degrees, although our localizer heading will be set at 303 degrees. We'll explain that in a little bit. And when you reach the procedure turn point, which is typically about 4.5 miles from your initial approach fix, turn to the right 164 degrees and fly the procedure turn back and intercept the localizer. Notice we need to remain within 10 nautical miles of the initial approach fix, and at coupe be something above 2,000 feet. And typically I use about 3,000 feet above the initial approach altitude, which here is at or above 2,000 feet. So you can fly outbound on the procedure turn. My technique is to fly for 36 seconds, then make a standard turn back and intercept the localizer. 36 seconds allows for you to continue the turn instead of straightening the turn out for a 30 degree intercept. But the traditional teaching there is that it's flown for 1 minute. Notice the minimum safe altitude circle that we must abide by, and that shows from the direction where we'll be coming from to be 3,000 feet. So we're in the Learjet, departing from Stockton Municipal, which is a fairly short hop away. So do our usual departure technique, accelerate to about 60 knots, N1 of 70%. Keep it on the center line here. And then once we get around 60 knots, we push the throttles forward to about 90%, 92% at the weight we're at here for takeoff. And positive rate and gear up, nose up at about 15 degree pitch. And we start our climb out and throttle back to a N1 of between 70 and 72% for noise abatement. As we get about 1,000 feet above the ground, we'll raise our flaps and push the nose, ensuring that we are well above the minimum speed for no flaps. Lower the nose to about 7.5 degrees to accelerate to somewhere around 240, 245 knots. Keep in mind, below 10,000 feet, you must stay below 250 knots, unless otherwise authorized. So we'll climb out, maintain the runway heading, and as we get towards 230, 240 knots, we'll raise the nose up a little bit and continue our climb out. We're climbing a little slower than usual here, but that's okay. And we can hold the nose down. We'll keep N1 at about between 70 and 72% for noise abatement until we're well up in the air. Don't want to disturb the fine folks of the Northern California area. Nice rate of climb, 3,500 feet per minute. Gets us up there fairly efficiently. And at 5,000 feet, we'll begin our turn to course. And we've already set our course. We'll just kind of dead reckon a little bit to Merced. Here you can see we've departed from Stockton, actually headed to the northwest. We'll be landing in that same direction after we make the procedure turn. But right now we're turning headed southeast on course to Merced. So a quick look at Plan G. Here is Merced down to the southeast, and we've made our turn around, and we're going to fly in the general direction of Merced. We can actually use the El Nido VOR to help us. Notice that it's just slightly to the left of the line that we want to be on, and so we can actually fly to the El Nido VOR and deviate just a few degrees from course as we get closer to line ourselves up with the localizer and fly outbound for our procedure turn. Take another look at that again. So we're coming in from the northwest, so we must abide by our minimum safe altitude of at or above 3,000 feet. When we came in from the other directions, you notice that coming over the mountains that there's a significant difference at 5,600 feet. We'll hit our initial approach fix, fly outbound on a 123 degree heading. The reciprocal of the localizer will actually be following the localizer. Right turn to 168 degrees, 36 seconds, and then turn back, standard turn, 348 degrees to intercept the localizer and fly inbound again. The 36-second rule works well. It allows you to make the outbound leg and turn with a standard turn inbound and basically intercept the inbound course without the need to hold a 30 degree or so angle off of that course for course intercept. The traditional teaching is that this is flown outbound for 1 minute. The FAA does allow you to do anything you care as long as you remain within the bounds of the procedure turn. And the reason that I shorten this to 36 seconds is first 36 seconds allows for an exact turn back done properly at the standard rate turn to intercept the course, and it also gives you a little extra margin against the 10 nautical mile limitation. If you fly out for 1 minute, you're at risk of going beyond 10 nautical miles from the initial approach fix. And as I've said before and others, almost every approach restriction requires you to remain within 10 nautical miles, although there are a few exceptions. So we'll hit the initial approach fix at probably about 3,000 feet. We have to maintain at least that for minimum safe. Make our descent down to at or above 2,000 feet as we make the procedure turn, and then fly the course inbound. So outbound, procedure turn, drop your altitude 3,000 feet down to 2,000 feet, 36 seconds, standard turn back, intercept the localizer, fly inbound on a standard ILS approach. And notice we will maintain at or above 2,000 feet until we reach the Coop intersection, and this will put us below the localizer. Here we are back in the Learjet, and we've started our descent. And we're tuned into the El Nido VOR right now. And notice that we're pointing a little bit to the left of El Nido VOR, and we actually want to be a little bit to the right of it. So there's the identifier. We're 37.7 DME out. And we want to be just a few degrees right of the direct course to the VOR. As you can see, the VOR sits a little to the left of the runway. And we're coming in from the northwest, so we'll want to move over just 3 or 4 degrees to the right to put us over the airport. An alternate technique would be to fly GPS direct, which would put you right over the airport, at which point you can adjust your heading accordingly prior to Coop, the initial approach fix. But this In this case, we're going to use the Inital VOR and fly just a couple of degrees to the right of the direct in course, and you'll notice that the course deviation indicator, the split part of the needle, will move slightly to the left. You can also see that we've got a little bit of wind from the left, not much, 7 knots. It is tending to push us a little to the right. So we don't need too much of a variation. The wind will blow us a degree or two to the right, and so we'll add another degree or two to that to end up over the airport. Here we are back in Plan G, looking at our course. We're kind of heading just a little to the right of the Inital VOR, pretty much on course to Merced, and making the coupe intersection on the localizer as required. So since we're not actually flying to the Inital VOR, we've changed the frequency to the localizer frequency of the runway 30 ILS at Merced. And notice that the needle is pointing in the direction of that we're going to land. That's the way you want to do this. You want to be able to fly always into the needle, and turning the needle in the direction for an ILS in the direction that you're going to land will allow you to make the usual correction of turning into the course deviation or split portion of the needle. So we're about 7.5 miles out now, and we've leveled off at 3,000 feet, giving us a little bit of time to slow down. We'll slow down below 200 knots, verify our frequency, verify that the heading is set correctly, verify that we are in fact on the ILS, which is the IMCE identifier. We'll zoom in a little bit here so you can see there's the airport, headed nicely to it. The moving map in the Lear, this version of the Lear with the modified panel, is very handy. So as I said, we'll slow down below 200 knots. I usually like to fly the Learjet on approaches like this at about 160 to 180 knots. Varies a little bit because of loss of altitude and so on, which you can gain a little speed. So we'll be coming in more or less directly over the airport. Intercept the localizer, make sure you're on the localizer by the time you get to the initial approach fix coupe. Fly outbound from there, so the coupe intersection at about 3,000 feet, heading 123 degrees, outbound for about 4.5 miles. This will allow you enough time to make the turn and remain within the required 10 nautical mile distance from the initial approach fix. So once we reach the roughly 4.5 mile point, we'll turn right, heading 168 degrees. Once I've am on the heading, the outbound heading, in this case 168 degrees, I time for 36 seconds for the outbound leg, and then start a standard rate turn back to the left to intercept the inbound course. You can estimate the bank angle required for a standard turn using 15% of your true airspeed. So if we're doing about 170 knots, 15% of that will be about 25 degrees. That's pretty much the steepest angle you want to fly under normal circumstances. Some aircraft are even limited to that bank angle, although most will allow you up to 30 degrees for standard turns and a little bit more for the maximum. So we make the turn back in again. If we make our outbound turn and then time 36 seconds, a standard turn inbound should put you pretty close to the inbound course and direct intercept of the localizer, and only small corrections required at that point. 2D panel up for a little clarity. You can see that we're approaching the airport, 3.2 DME at this point. And the localizer needle is showing us that we are to the right, of course, the split section being off to the left. Keep in mind that we have plenty of time. We cross the airport and only need to be onto the localizer by the time we get to the coupe intersection, the initial approach fix. But we can make a small adjustment at this point and begin to center that needle. Makes things a little bit easier. Notice that it looked like suddenly we were on the correct course, but in reality, notice we've lost the indicator of the ILS. That means we've gone into the dead zone of the ILS as we fly over it. Typically you will still have DME, but the dead zone for the actual localizer signal is about a mile or so, depending on your altitude. Typically at approach altitudes it's a mile, maybe a mile and a quarter. And you can see that we've crossed over and the distance is increasing. We're flying at a heading of 123 degrees, although the needle is pointing at 303 degrees. We want to make sure that that's the correct one. Actually, I've set the course here at 305 degrees because FSX is living in the early 2000s, and the approach plate we're looking at is from 2015. So a small amount of magnetic change. So we use the actual FSX one, since that's the world we live in here. And you notice as we got the signal back, the course deviation indicator was to the right, meaning that we want to now move to the right a little bit in order to intercept the localizer. And once we do, we'll fly outbound to the coupe intersection, keeping the needle centered. And that way we've intercepted the localizer early. We know we'll be at the proper place, which is the coupe intersection, 6.5 DME on the localizer. Then we'll fly outbound another 4.5 miles approximately. So that'll put us about 11 DME from the localizer. And then make the turn, 168 degrees, fly 36 seconds, standard turn. Again, bank angle for a standard turn estimated as 15% of your true airspeed. Hold that turn, and that should bring us very close to intercepting the localizer without the need for any kind of intercept angle. If you choose to fly the standard 1 minute, you will have to hold some degree of intercept angle for several seconds. Remember, remain within 10 nautical miles. Start at coupe at 3,000 feet. We descend in the procedure turn. Once we begin the procedure turn, you can begin the descent down to at or above 2,000 feet. Here we are, we're 5.5 DME out from on the localizer, so just about a mile from coupe. And when we get to the coupe intersection at 6.5 DME, we'll make our turn to the right. Staying on the localizer, you can see on the moving map here where we are. Not a lot of help here in this case, but it does provide some visual reference. We're flying past the El Nido VOR right now, just off to our left, and about a little more than 7 DME on the localizer. And we want to fly outbound, remember, from our initial approach fix, which was 6.5 DME, about another 4 to 4.5 miles. That'll put us 10.5 or 11 miles out before we start our procedure turn. The needle deviates a little bit to the right. We want to move to the right because we've got the indicator pointing in the direction that we're landing. So this allows us to follow the usual rules of fly into the heading deviation portion or split portion of the needle. Bring up the 2D cockpit again for a little bit more clarity. Here we are, we're on the localizer. We're approaching 10 DME from the localizer DME measurement point. And we'll, like I said, begin our turn, usually 4.5 miles from the initial approach fix. So we've begun our turn to 168 degrees, and once we reach 168 degrees, we'll time for 36 seconds, and then make our turn back in to intercept the localizer. Once again, the course here is 305, although the approach plate shows 303 degrees. This is due to, as I explained earlier, the magnetic drift difference of around 2004 to 2015. So outbound 168 degrees for 36 seconds. And since we're now in the procedure turn, we can begin our descent down to 2,000 feet. We'll do that gradually here. As you can see, a descent rate of about 500 feet per minute is all that's needed. And we'll switch back over and show you that we've already set up for the initial portion of our landing. Flaps at 8, set the power to maintain our speed properly, and hold a heading of 168 degrees. 36 seconds once we've made the turn, and we start our turn back. In this case, we'll do a standard rate turn. Approximately at this speed would be approximately 27 degrees bank angle. So we'll tighten it up just a little bit and continue our descent down to 2,000 feet. And keep in mind, as the airspeed drops off, as you level off at 2,000 feet, you can shallow out your bank angle just a little bit. So we'll move it back down to about 25 or 26 degrees as we arrive at an indicated airspeed of around 170, which at this altitude is fairly close to your true airspeed. So you can use indicated times 15% to determine your bank angle also. You'll notice here we're 15.4 DME on the localizer. If you subtract the 6.5 from that, we remained well within the 10 nautical mile requirement. We can take a quick look at Plan G and see where we're at. The Coop intersection. We flew outbound for about 4 miles or so. We can measure that. If you watch the QDM measurement on Plan G, you'll see that we're just under 4.5 nautical miles. And we'll move the information box down a little bit so you can see that. So this is our point of interest here, and you can see the QDM range and bearing. And if we move back to where we started, it looks like about 4.4 or 4.5 nautical miles. And we'll switch that off, get rid of that. You can see that we intercepted the localizer, flew from Coop to about 4.5 miles out, started our procedure turn, continued on for 36 seconds, and began our standard turn back inbound. Holding this turn using 36 seconds, we should be pretty close to intercepting the localizer once we complete the turn. So we'll get back in the cockpit now again and continue on with this approach. And we're holding that turn. Here we're down to just below 160 knots, and you can see that we're nearing the localizer, and we'll begin to shallow out a little bit, hold a little bit of an angle just to let the needle settle down, and then turn once we are close to intercepting and fly inbound. At this point, it's a fairly standard ILS approach, not a whole lot different from any others. It just involved a different kind of procedure turn. Here you can see we're pretty close to being lined up on the runway, just a fraction of a degree off, but we will make that final little correction and get ourselves right dead center on the localizer. And you also notice that we're still well below the glide slope at this point, and we'll expect glide slope intercept at about the initial approach fix Coop, holding it to 2,000 feet at or above until then as required, as shown on the approach plate. So at this point we'll take a look again at what we just did, and you can see that we again flew outbound from Coop 4.5 miles, right turn to 168 degrees, 36 seconds, left standard turn, put us almost exactly on the localizer. We flattened out just a little bit, and now we're flying inbound. So we'll continue inbound, holding 2,000 feet until we get to Coop. This is according to the approach plate, which shows that you're required to maintain an altitude at or above 2,000 feet until you intercept the localizer, which is just before you get to the Coop intersection. So we'll continue here, and then once you hit that, you can fly down the glide slope and make the landing. And since this is a fairly standard ILS approach at this point, we'll make a little variation on the theme. Notice here, still well below the glide slope. You always want to intercept a glide slope from below, never from above. There are false echoes of glide slopes above that can be very confusing. You could hit the approach switch here, but we're going to hand fly this in and do a little bit of a variation on the theme. Since this is otherwise a fairly standard approach. So we're at 20 degrees flaps. When we intercept the glide slope, we'll drop flaps and drop the gear as per the standard procedures. Right now, just a little bit before Coop, nearly on the glide slope, so the gear is coming down. We'll watch for 3 greens. 3 greens, and we've intercepted the glide slope. Lower our flaps and proceed down. Our little variation that we're going to make here is we'll fly the glide slope down until we're near the end of the runway, then practice the early touchdown technique that you would want to use if you have a wet or icy runway. You want to have as much runway available so you'll touch down before the touchdown zone. But what this requires is that you remain on the glide slope until near the end of the runway and then duck under the glide slope a bit. The tricky part in that, in an aircraft like this especially, is that if you push the nose down to touch down early, you gain airspeed, the aircraft tends to float, and you end up floating farther down the runway than had you just done a standard landing, so we don't want that to happen. You can also help yourself by getting rid of a little extra speed. We're a little to the left, as indicated by the deviation portion of the needle, so we'll move it over to the right. In the description, I've included a link to a video by Guido Warnecke. These are some excellent videos. And if you don't want to look at the whole thing, although it's got some beautiful scenery, at about 11.5 minutes in, you'll see him demonstrate the technique of the early touchdown. He also makes the point of shutting down your reversers at or above 60 knots to avoid sucking in any bad things into your engines. So here we are on the glide slope, and now we're going to duck down just a little bit. We have our airspeed a little bit lower than usual, but we'll try and maintain a fairly flat angle and see if we can't touch down pretty close to the numbers. This would give us about an extra 1,000 feet before the touchdown zone, which is we are crossing right now. So in the case of a wet or icy runway, that extra 1,000 feet might make a big difference. Thrust reversers on. Remember to shut them down at or above 70 knots to avoid sucking in debris. And we can slow down and make the right turn and exit the runway from here. So once again, a little bit of a review. We came in from the northwest, overflew the airport, flew outbound, intercepted the localizer. Although you can see initially we were just a little bit off, but we did intercept the localizer well before the initial approach fix Coop. If you notice the scale here, we'll move this out of the way. 2 nautical miles. Eyeballing this looks like just a couple of tenths at the most off the localizer. About halfway between the airport and the initial approach fix Coop we were on. Flew outbound 4.5 miles. Right turn 168 degrees, 36 seconds. Standard turn inbound. started to pick up the localizer. We flattened out just a little bit to slow our turn down, and flew on course for a standard ILS approach. Thanks for watching, and do check out that video by Guido Warnecke. The link is posted in the description of this video, and if you move to the about 11.5 minute point, you'll see the early touchdown and also the standard procedure of retracting thrust reversers at or above 60 knots.